Okay, so agriculture is the largest source of nitrous oxide emissions in the US. Nitrous oxide is a greenhouse gas around 300 times more powerful than CO2. Nitrogen fertilizers are the source of most nitrous oxide emissions, and it also results in the leaching of nitrate, which impacts water quality. Therefore, nitrous oxide mitigation must also consider water quality and crop yield in order to meet the food demands of a growing population. The objective of this study was to evaluate trade-offs among crop yield, the leaching of nitrate, and nitrous oxide emissions from land uses and management practices at a watershed level to facilitate the decision-making of multiple stakeholders. This study combined several modeling based on Iowa soils and weather conditions, as well as management practices. The nitrification decomposition model was used for outcomes for corn, switchgrass, green beans, and grapes, using different soil types, precipitation levels, specific nitrogen fertilizer application, and a simulated time of 20 years. The Intergovernmental Panel on Climate Change Modeling was used for outcomes for grazing and poplar trees. 5 land use scenarios were modeled using the PIWI modeling tool. Scenario 5 divided the watershed equally between conventional corn, which uses tillage, and permanent grazing, in which cattle are allowed to stay on the pasture. Scenario 2 is a conservation version of scenario 1, in which conservation corn uses no-till and cover crops, and in which rotational grazing allows or moves cattle from paddock to paddock to allow for even grazing. Scenario 3 models corn under both conventional and conservation practices. Scenario 4 uses conservation corn, switchgrass, which is a perennial grass used for bioenergy and grows easily, and an equal distribution of mixed green beans and grapes. This scenario, all the land uses in this scenario are conservation practices. And finally, scenario 5 uses conservation corn, switchgrass, rotational grazing, and adds poplar trees, which are used for bioenergy and grow really fast. Model results show that switching from conventional corn and permanent grazing to conservation corn and rotational grazing lowers nitrous oxide emissions and the leaching of nitrate. It also benefits the yield of livestock. The highest nitrous oxide emissions and leaching of nitrate was observed when only corn was planted in scenario 3, even when half of the land used conservation practices. The highest crop yield of all scenarios that only use conservation practices was observed in scenario 4. And it is also better, that scenario is also better at mitigating nitrous oxide emissions than nitrate leaching. And then the lowest nitrous oxide emissions and leaching of nitrate was observed under scenario 5, but that also had the lowest yield for both corn and livestock. To summarize, conservation land uses and practices mitigate nitrous oxide emissions and the leaching of nitrate. Corn production results in the highest nitrous oxide emissions and leaching of nitrate, even when conservation practices are used, implying the need for additional mitigation strategies that were not modeled in this study. And that is important to consider because corn is the most cultivated plant in the US. And finally, PIWI simulations can assist in attaining sustainable agriculture to mitigate both nitrous oxide emissions and the leaching of nitrate. But then it also has to consider other greenhouse gases like carbon dioxide and methane. So my gratitude to my assistant principal, Lori Oller, for supporting me in this project as we go into the school year as well. A special thanks to Dr. Lisa Schulte-Moore and Richard Magala and the CSATS team. Thank you.